physics says, well, what happens is that whenever you do something on one photon, the reaction is not on this photon only, but there's a global reaction of two photons. In some sense, the two photons, although they are at this large distance, they still constitute one system. And so the global system reacts at once. And this is quantum non-locality.
Jizan sends photon signals through fiber optic cables stretched across Geneva. A pair of photons on one end is activated with a laser, and the photons on the other end instantly react. Nothing seems to move, and no energy is exchanged. Yet, somehow, the particles share information.
Einstein used the word spooky action at a distance. So this spooky action at a distance is not something that travels in space-time. It's not something that happens in space-time. There is no story in space-time that can tell us how these non-local correlations happen. And that's why we conclude that they seem to emerge somehow from outside space-time. So that has, of course, deep implication for our understanding of space-time, or actually more precisely for our non-understanding of space-time.
Some believe that quantum non-locality can be used to send messages backward in time. At the University of Washington, physicist John Kramer is putting this idea to the test. Like Jizan, he's experimenting with entangled photons, photons bound by non-locality. The twist is that Kramer is trying to send photon signals from the present back to the very recent past. These custom-made lasers and measuring devices called interferometers are the heart of Kramer's time machine. One interferometer called Alice sends photon signals to another interferometer called Bob. If Kramer's theory is correct and the calibration is just right, Bob will get a message from Alice a fraction of a second before she sends it. Cause and effect will be reversed.
So Alice has control over whether we have particle-like behavior or wave-like behavior over here. Because the photons are entangled in the space, Bob, who wants to receive the signal over here, can look and see whether he has an interference pattern at the same time. Now, this distance is a few centimeters. It's not very big, but it doesn't have to be a few centimeters. This could be a light year down the line, and she could still do the same thing and cause the same effect over here. And that's the way entanglement works. And so if I put a spool of fiber optics in here that's, say, 10 kilometers long, then she would send the signal 50 microseconds after Bob received it. So she would be sending messages backwards in time by 50 microseconds. So one could use it in principle for backwards in time communication.
If Kramer's device works, it will only send messages back a millionth of a second before they're sent. But a signal showing itself even a tiny bit in the past would revolutionize our understanding of time. It would prove that retrocausality, the theory that events in the future affect events in the past, is true.
If it does work, it would be quite remarkable. It would be a big deal in physics. It would be a big deal in the communication industry. And if you could send messages backwards in time, it would be a big deal everywhere. It would change our civilization in ways I have trouble imagining. But all of that is probably just an indication that the experiment probably won't work, because nature probably doesn't want to allow you to send messages backwards in time.
I don't really see retrocausality as a very plausible assumption. I mean, time clearly evolves or gets constructed towards the future. On the other side, I would also say that time is certainly a very poorly understood concept in physics or by physicists today, and one can certainly expect that in the future we'll have a much better and deeper understanding of time, and possibly a very different one from the one we have today.
So let's say that someday we develop that better understanding of time. After solving the riddle of quantum gravity, we build a working time machine. What would happen then? Would we be able to change the past? The answers are fantastic, disturbing, and a little strange. We're trying to send signals back in time. And if that works, perhaps one day we can send humans back in time. An exciting idea, but it opens the door to the problem of paradox. A paradox is a situation that contradicts itself. Doesn't make any sense. Say you send a cure for cancer from the future to the past. Would the dead now be alive? See? Time travel is filled with such mysteries.
The things we would like to understand about time travel are, one, is it possible, even in principle, do the laws of physics permit backward time travel? We don't know the answer. We need the laws of quantum gravity in order to find out the answer. Second question is, if backward time travel is possible, then what does nature do about the so-called grandfather paradox? That I can go backward in time, then, if it's possible, and kill my grandfather before my father was conceived, thereby changing history so that I no longer exist. What does nature do about that?
The conservative interpretation is that space-time is one four-dimensional thing. It doesn't change. So if time travelers go to the past, they were always part of the past, and they don't change it. In other words, if you had time travelers aboard the Titanic, they might have warned the captain about the iceberg, but he didn't pay any attention to them, like he didn't pay any attention to the other iceberg warnings, because we know the ship ended up hitting an iceberg. So that's the conservative view, that time travelers don't alter the past. They can participate in the past. In fact, one wag once said that the real thing that sank the Titanic was the extra weight of all the stowaway time travelers on board to see it sink.
In fact, there is a simple reason we aren't surrounded by time-traveling tourists from the future. It's because no one has built a working time machine. Even if we someday have the technology to travel back in time, the machine will only work starting at the point we invented, creating the first loop in time.
When you create a time machine by moving cosmic strings up in the year 3000, you create a time loop up in the year 3000 by twisting space and time. So when the time traveler goes, he goes always toward the future, like this car. So he goes around the loop, and that means that he can go from the year 3002 back to the year 3001, but he can't but come back here to 2010 because that's before the time machine was built.
But there may be an exception to these rules. And, once again, it grows out of the weird world of quantum mechanics. Many quantum physicists believe there is an incalculable number of parallel universes, and these parallel universes are all around us.
Every time you make a decision that could have gone one way or the other, or you flip a coin, for example, it could have gone the other way, and then the universe would branch off into two separate branches in the many worlds theory of quantum mechanics.
If you allow for alternate universes, then lots of things can happen. It's still true that you have to avoid logical paradoxes. It's still true that what happened did happen, but it means that what happened in one universe happened in that universe. It doesn't apply to the new universe.
If the many worlds exist, which they do according to quantum mechanics, then what you would do is you go back to kill your grandfather. You kill a man who is identical to your grandfather, but he is only your grandfather in a parallel world. in that parallel world, your grandfather, being killed by you from another universe, is never going to give rise to your father, hence to you. But that's no problem, because you have never existed at all in this universe. What you've done in your time machine is cross the universes.
But there seems to be little chance of time traveling anytime soon, either into the existing past or a parallel universe.
The technology that would be required to make a time machine that has even a whisper of a hope of success is as far beyond us today as space travel is beyond the capabilities of an amoeba, because our technology is so puny. There's no hope at all.
Time travel seems unlikely if we approach it purely as a matter of taking a person or information from the present and transporting it to the past. But there is another way to journey into the past, a way that until recently would have been considered preposterous, but it's getting closer to reality every day. We could build the past. Human technology is evolving exponentially. When our computers get powerful enough, they could simulate massively complex worlds, including past eras of life on Earth. These wouldn't be video games. These simulations of the past would look and feel so real, you wouldn't know they are simulations. Not the genuine past, but the next best thing.
If you really want to go into the past, you're going to have to go into the extreme far future. In the extreme far future, they will have the ability to reproduce the past. And then you can see what the past was like. You can actually experience the distant past by existing in the virtual reality of the computers of the far future.
We've seen that time travel into the distant future is possible, but it's a one-way trip. Time travel into the past might be theoretically possible, but it requires inconceivable amounts of energy and technology. Our best hope may lie in computer recreations of times past. So it looks like we won't be able to go back in time to visit the people we've lost, or correct the mistakes we made when we were young. Our trajectory through time, from birth to death, is the one thing all living things have in common. Every human has to live with the fact that life is short and time is precious. We have our triumphs, we make our mistakes. If we could go back and correct those mistakes, would we ever learn anything from them? Would we be the people we are today? For now, at least, we can't turn back the clock. But we'll keep trying. We will keep trying.